You know, humanity is right on the verge of becoming a multi-planetary species. But how we actually get to Mars and what we do once we get there, well, that's at the heart of one of the biggest debates in science and engineering today. Right now, there are two huge competing visions for our future on the red planet, and in this explainer, we are going to break them both down.
But here's the thing. To even begin to talk about the future of Mars, we have to understand its past. And it turns out we've had a big piece of it wrong for a long time. For years, scientists picked Jezero Crater for the Perseverance rover because all the signs pointed to it being a calm, ancient lakebed. The perfect spot to find preserved signs of life. But when Perseverance actually started drilling, it sent back data that just completely rewrote the story.
So instead of finding that quiet lake sediment they expected, Perseverance hit igneous rock that was forged in the fire of ancient volcanoes or cooling magma. And what's even crazier is that this volcanic rock shows clear signs of being changed by liquid water, not just once, but multiple times over. This discovery paints a picture of a Mars that was way more dynamic and geologically active than we ever really gave it credit for.
This whole thing is just a powerful reminder that Mars still has some deep secrets. But as we're piecing together its ancient past, an even bigger question about its future comes up. What is it going to become? And this, right here, is where the two great visions for humanity's next chapter really collide.
Okay, first up, you've got the incredibly audacious vision from SpaceX. And I want you to forget about a small research outpost. This is about building a city, a permanent, new branch of human civilization on a whole other world.
Elon Musk has been absolutely crystal clear about this. The ambition isn't just to visit Mars, it's to stay. The goal is a completely self-sufficient city, one that doesn't need to depend on Earth to survive. And that single philosophy, it drives every single design choice they are making. Now, the engine for this whole vision is the Starship. So why is this stainless steel beast such a total game changer? It all comes down to one thing. It's designed to be fully and rapidly reusable. That's the key. That reusability absolutely slashes the cost of getting to space, and suddenly, a city-building project on Mars becomes economically possible for the first time ever. We're talking about a vehicle that can carry 100 metric tons of cargo or up to 200 people. It's basically the fleet of interplanetary trucks you'd need to build a new world.
And if you think the vehicle is crazy, check out the timeline. SpaceX is aiming to launch its first uncrewed cargo missions as early as 2026. A year later, they'd land and deploy Optimus robots to start building out critical infrastructure. And if all of that goes to plan, the first humans would follow in 2029. Now, it is a timeline that a lot of people in the space community think is almost impossibly optimistic, but it just shows you the sheer scale and speed of SpaceX's ambition.
All right, now let's pivot to the second grand plan, the one from NASA. And it's a huge contrast, both in its final goal and how they plan to get there. This vision isn't about colonization at all. It's about pure, systematic, scientific exploration.
So, NASA's playbook is this incredibly detailed document called the Design Reference Architecture 5.0, and its focus is completely different from SpaceX's. This thing is the blueprint for the first 3 crewed missions, and it's all designed to do groundbreaking science and just learn how to operate on a distant world, building a solid foundation of knowledge for whatever might come next. At the very heart of their plan for the surface is what they call the commuter concept. Picture this. Astronauts would live and work out of a central habitat, and then use it as a home base to go on these long-range scientific road trips in pressurized rovers. This model is all about being mobile and discovering things, letting a small, highly trained crew explore a huge region and answer those fundamental questions about the planet.
In the why behind their mission, it's pure science. We're talking about the biggest questions out there. Was there ever life on Mars? How did its geology and climate evolve? And critically, how can we learn to live off the land using something called in situ resource utilization, or ISRU? Basically, that just means using Martian resources, like the CO2 in the atmosphere and water ice, to create breathable air, water, and even rocket fuel. Each mission is like a building block of knowledge for our future in space.
So, we've got 2 radically different goals. But here's the thing. No matter what the mission is, both plans have to solve the same mind-bogglingly difficult technical challenges. So let's break down how their approaches to these hurdles stack up.
First up, the ride to Mars. Starship runs on methane-fueled Raptor engines, but to actually make the trip, it's going to need to be refueled in Earth's orbit by a whole fleet of tanker ships, a super complex orbital dance that has never been done on this scale. NASA, on the other hand, is betting on a nuclear thermal rocket, or NTR. This tech uses a compact nuclear reactor to superheat propellant, giving it a much bigger kick. That extra efficiency could seriously shorten the 6 to 9 month journey, which is a huge deal for reducing the crew's exposure to dangerous deep space radiation.
For SpaceX, the landing is the ultimate challenge. Nothing even close to the mass of a 200-ton Starship has ever landed on Mars. I mean, they have to perfect every single step, get to orbit reliably, master that orbital refueling, survive deep space, and then somehow slow a skyscraper-sized vehicle from 7.5 kilometers per second all the way down to 0 for a soft touchdown. Each one of those steps is just a monumental engineering feat on its own.
Okay, so once you're on the surface, you need power. A lot of power. SpaceX's city plans rely on rolling out these massive solar arrays. To generate enough energy just to make the fuel to get home, estimates say they'll need panels covering an area equal to about 7 American football fields. NASA's plan goes a different route, a pre-deployed nuclear fission reactor. It's way more compact, and it provides a steady, reliable stream of power, day or night, even during one of those infamous planet-covering dust storms on Mars.
And who's going to do all the work on the ground? This is where you really see that philosophical split in action. NASA's plan is built around human explorers, scientists and engineers in rovers doing hands-on research. SpaceX is betting big on automation. They plan to send an army of bipedal Optimus robots to build the base and prep the landing zone before the first humans even leave Earth. It's a really fascinating contrast. Human ingenuity on the spot versus advanced robotics laying all the groundwork.
But beyond all the rockets and the robots, we have to remember what's really at stake here. Incredibly brave and very vulnerable human beings who are going to be pushed to the absolute limits of their endurance.
NASA has identified 5 primary hazards for any human mission, and how each plan deals with them is critical. Take radiation. NASA's faster nuclear thermal rocket is a direct attempt to minimize that exposure. SpaceX's longer trip means they're going to need some seriously robust shielding. Then you have isolation. For a small NASA crew of 4, the psychological pressure is going to be immense. But would being one of 100 people on a Starship, part of a growing colony, make that better or worse? And for distance from Earth, NASA's methodical, high-redundancy engineering is all about preventing problems, because there's no rescue mission coming. SpaceX's approach, redundancy through numbers. Send many ships so that even if some fail, the overall mission can still succeed. It's a completely different risk philosophy for protecting human life so far from home.
So as we pull back, you can start to see 2 fundamentally different futures being mapped out on the exact same red planet. One is a future of permanent settlement, and the other is a future of pioneering exploration.
So let's just lay it all out, side by side. On one side, you have SpaceX. The goal is a self-sustaining city, the scale is massive, thousands of people, and the pace is just relentless and iterative. Their philosophy is all about redundancy through numbers. Send a lot of ships and expect that some will fail. Then on the other side, you have NASA. The goal is scientific discovery. The scale is small and focused, and the pace is methodical and systematic. Their philosophy is redundancy through painstaking engineering. Get everything perfect before you go. This quote from Casey Dreer over at the Planetary Society really just sums up the whole feeling around the SpaceX plan. It's so ambitious that success is far from guaranteed. The technical and the human hurdles are just immense. But then again, SpaceX has a pretty good track record of achieving what seems impossible.
And that leaves us with the ultimate question. It's not for the engineers or the billionaires, but really for all of us. As we stand here on this incredible cliff in history, what do we want Mars to be for humanity? Is it a backup drive for our species, a new home, or is it the greatest laboratory in the entire solar system, a pristine world for pure discovery? The path we choose will absolutely define our future in the cosmos.